All right. So it's already 2:06. Very few people, only three of you are there. Should we? Okay. F- right. It's a Sunday, so probably the number of people are less.
Hello. Can you see on your side the Masumba? He's saying he want to be let in, but on my side I cannot see him.
No, I can't see him. I
Masumba,
can't
you
see.
can see him as well.
No.
Okay. Yeah, I have two people who says they want to join, but I can see them.
Are they using the same link, Farida? Just share the link with them. I hope there's no confusion in the link.
I don't know. I texted on WhatsApp that the class is starting, so they are
Okay.
also responding on WhatsApp. So let's just see.
All right.
Good morning, Datta.
Yep. How are you?
Fine, ma.
All right. Uh,
It's afternoon for Rob. Good afternoon.
yeah, good afternoon, Usman. How are you?
I'm fine.
And you're from where, Usman?
I'm from Nigeria.
All right. And you're doing what?
Yes.
No, what do you do for your profession?
I'm accounting clerk
Okay.
in one private organization.
And why are you doing this course?
Because I like the figures.
Okay. All right. Good.
That's why I enjoy your class yesterday.
All right. Good. Good to hear that.
Thanks.
Thank you. All right.
Thank you.
Farida, just kindly, if you can, just share the uh, what the or anybody in the on WhatsApp can share the link and see whether they are on the right page, because otherwise,
Okay, ma'am. I'm trying to share the link.
right, please. I suppose there are two links. Are there two links for today's thing? No. Okay, we have got a 7 to 9 link. We have got a link for 7 to 9. That's a separate one. I don't know. Okay. Uh, Okay, let's start. Let people join in, and they'll be joining in. Let us start. Yesterday we had spoken about the measure of central tendency, and today I'll start off with uh, dispersion. That is what I'm going to start. And any questions from yesterday? Any queries from yesterday's lecture? Anything that you people want to ask, or we can move ahead? Any queries? Okay. So we are starting off with dispersion. Basically, that's the next step, and it's also a part of your descriptive statistics. So this is a aristocracy from England, Michael de Montaigne, who said that there never was in the world two opinions alike, no more than two hairs or two grains. The most universal quality is diversity. So this is what he had to say regarding diversity, and dispersion is all about diversity. So what here we are talking about is we say that it is. The various measures of dispersion that you have, they are a part of the descriptive statistics, and like you what you are trying to do is how similar a set of scores are to each other, uh, and you like from your measures of dispersion you found out a single figure, you found out a central figure, and now you want to find out that from that central figure how far or how near your other variables are. So say supposingly you have got 10 numbers, and out of those 10 numbers, like you have 10 numbers, like if I may just all right. So mm, fine. So we have got numbers 25, 20, 10, 6, 4, 5, 3, 2, 7, 3. Now the total here, if I want to say the total is equal to how much? 45, 65, 75, 80, uh, 95, 105. So our total is 105. So the mean, sorry, or the average that you'll get, sorry, the average that you'll get is 105 oblique 10, which comes out to be 10.5. Now, this is your average or the central figure that you have got, and you are talking about this number. Now, you want to find out that how far or how near these other variables are, or observations, like how far or how near these observations are to 10.5. So this is what dispersion is. So if like here, if we want to find out the difference, we say that this is uh what 13.5, or rather 14.5, sorry. uh this is 14.5 is the dispersion here. Then it comes to be 9.5. Then you have got again 9.5. It was all right. Then you have, so how much a difference is there from this average that you are getting? So what we are saying here is that more similar the scores are to each other, the lower the measure of dispersion. The less similar the scores are, the higher will be the dispersion. So, and why am I interested in finding out the dispersion? Now, if I come back All right. So all people who were attending yesterday are not here. Most of them are not here, or I don't know. Like I did not speak to a lot of you yesterday. So like let me come back to what Farida, because I know what Farida does. So Farida is in the, yes, Farida, you want to say something?
Yeah, I still
Mm.
have two people still waiting to be joined in, but I
Okay.
still can't see them. Yeah, Masumba is still trying.
Mm.
He's saying he's still waiting for us to join
I,
him.
is he? Please ask him that has he joined the evening link, because there are two links for today. There is a class from 7 to 9 Indian Standard Time. Is he
Okay.
there? Has he joined
Okay.
that link?
Let,
Uh,
let me ask him.
Yes, I
yeah.
have joined, ma.
Okay. You are here.
Yes, ma.
No, Muhammad is Farida. Who are those two people who are wanting to join in? Okay, I suppose. Let mm, Farida, did you get a response? Okay, Masumba is here.
Yeah, he's finally in, so it's okay. You can continue. Sorry, sorry.
No, no, it's okay. So, Masumba, did you join the wrong one? Okay. Masumba? All right. Uh, Fine. So I was taking Farida's example that Farida works for the hospitality industry, and she has got like mm, what should I be taking her example? Okay. Say supposingly you have got the average number of customers coming in. So, sorry. So from the average number of customers that she is getting, like yesterday we were talking that when are the peak days and when are the lean periods. So she said that weekdays are better because it's mostly the government people who are government employees who are coming and staying at a hotel, and so those are the peak days. But then you have to find out the dispersion. Say supposingly you are finding out monthly average, and so you find out that every month how much is the variation from that central figure that you have calculated, because there should not be a very high variation, because she is catering to the employee class. So it's not like if say supposedly a hotel was for the tourism for tourists, then we you can expect a dispersion, because for tourism again there are always the peak periods and then there are always the leaner periods, so that dispersion is understandable. But in her case, I suppose like that is what I'm presuming, that there should not be a lot of dispersion. Farida, is there a lot of dispersion in the monthly figures? Is there a lot of variation from the average?
Yes, yes. There are variations.
Very high variations or a slight variation?
Slightly. No,
Slight.
not really. Yeah.
Yeah, say supposingly in one like monthly average, how many customers do you people get on a monthly basis?
I'll put it at 240, 230.
Okay, and so that is around which you are like it might go up to 250, it might come down to 220,
Yes,
210
yes,
in a
yes.
month, right? Yeah. So yeah, that is also, this is the dispersion, and from this you can find out that her hotel, there is not a lot of change. That means their service, there is a consistency in the services that they are providing. There is a consistency in the loyalty shown by the customers there. So that's the reason that you calculate your dispersion. There should not be, same is the case with Musamba, like he's selling Toyota cars. So there, Musamba, is there a lot of dispersion in the monthly sales figures? Musamba, can you hear me?
Oh, sorry. Oh, yes, I can hear you now.
Yeah, okay. Thank God that you could join, huh? You joined the wrong link.
I used the one that was provided in the email, so must
I
have
think
been
so.
a
I think so. You joined the evening one,
uh,
because we have got a class in the evening as well. Yeah.
no, no, no. I used for the one for the afternoon. So
Okay, whatever. Okay, now tell me that how much is your monthly average sales?
um, in terms of monthly average sales, we're looking at uh, our the new vehicle sales market in Malawi is quite small. So
Hmm.
in terms of sales, we're looking at between 100 to 150 units a month.
And is there a huge dispersion every month? Like, is there a great variation from that 100, 150 that you're talking about? Is though 100, 150 is a huge range that you're talking about. So, if you say 100 units you are getting, is there a huge fluctuation every month from this figure, or does it stick around 200, 110, 20, 30?
Usually it does. It does. You've got other months where you do better than that. Actually,
Mm,
where there's some months where you do around 90 something. Other
mm.
months you do around over 170 some. So, and there would be those months where demand is exceptionally high. That there are certain factors that have happened in the market
Ah,
that have,
yeah, yeah. What
yeah.
are those factors? What are those factors?
For instance, things like COVID-19 happening.
Mm, mm, mm,
COVID-19 happening meant government, there were donors in the market.
mm.
There were
Okay.
donors in the market. People, World Bank pumped in money for the
Mm,
response. So
mm,
hospitals, the response team needed vehicles. So this
mm.
is abrupt demand.
Okay, okay. But that is
All of
that was during COVID. But right now, in the post-COVID scenario, what are you seeing? Is there a huge fluctuation, or
yes.
is there a constant, like it remains almost constant?
The market is not constant because at the moment, as a country, we are facing forex shortage. Yeah?
Okay, okay.
Yeah, so this what it means that for you to buy cars, you need forex. So if you can't
Mm,
buy cars, no matter how customers will come and pay in kwacha, in the local
mm,
currency, but
mm.
you can't bring in the vehicle. So demand has significantly gone down from selling 100 in a month to selling 20, 25, around 25. So
Okay, and why like why do you require foreign exchange to buy cars? Why can't we buy it in kwacha?
um, reason being is that where the cars are coming from, they want to be paid in their currency, isn't it? So
Okay,
the
okay,
country, the
acha,
central
okay.
bank.
Like for you, oh, but like as a customer, I'll be paying in kwacha, or I will be paying in American dollars.
Now, customers here will pay in kwacha, but for us as a company to get the vehicles here, we need to pay.
Okay, all right. Okay, understood. That's a okay. The supply side problem. There's a supply side problem,
Yes.
not as much as a demand side problem. Okay, all right,
Mm.
fine. Thank you. So this is what we try to do in dispersion, is that we are trying to find out that difference. That if he says that it's 100 vehicles, or 120 units that they are selling every month, and then it goes down to 20, so then that is a cause of worry. And like he has the reason that, okay, fine, we are having a foreign exchange crisis, so we don't have that much of foreign exchange to get the cars. or if there is a sudden boom is all like you can always argue that why should we inquire about the boom, because it's good that the business is doing good. The reason we also inquire or we are critical about the boom as well is that is it a one-off instance, or is it, can that be sustained? Like in case of COVID, that's a one-off, because nobody would want a COVID all the time, or nobody would want such a medical emergency at all times. So you don't want that. But say supposingly you say see a constant increase, like going beyond your average for 4 consecutive months, and you see that there's this like either like the government has increased the pay scale, there's a pay revision that has taken place, so then that can be sustained. That means now the company needs to re-strategize and to come up with a policy where they can sell more. That is what it is. So now you have got two figures here, uh, the top one and the below, the lower one. The question is that which of the distribution of score has the larger dispersion? Where are you seeing the spread of the data more? In the first diagram, in the top one, or on the bottom one? You can put on your mics and you can let me know, because I can't see you. Which has a larger spread, the top one or the bottom one?
The top one.
The top one has a larger dispersion. Okay. All right. Yes, the top one has a larger dispersion as compared to the because this is the answer to it, because the scores are more spread out. Like if I go back, if you see it here, you see that this is your center, this is the center, and from here you are going, and this is the spread that is happening, and from here again you go, and this is the spread that you are getting. So it's a more wider spread that you have got. On the other hand, here it is a more taller structure. It's a more taller structure, but then again, the dispersion is less. That means the spread is less. So the right answer, as he said, is the top one. So this is the right answer to it. Now, what is the significance of measuring dispersion? That why, as asked you, we were talking earlier also, that why do I need to find out the dispersion? Like I've found out a central tendency, I found out a central figure. Why now do I need to find out the variation from it, dispersion from it? You want to test whether the average that you have calculated, is it reliable or not. If there is a high fluctuation, that means there is a huge variation that is happening, that means your average is not reliable. So coming back to what Musamba was saying, or Farida was saying about the sales and things, you have to understand that how reliable your average is, that whether it is it showing you the right thing, or is it not. So that's one of the reasons. Second reasons is to, you want to control the variability, that if that fluctuation is happening, you do not want that fluctuation. Fluctuations are never good. Like Grace has now joined us. Grace, on an average, what's the sales like in your company in terms of customers? If we are talking, how many customers do you serve in a month on an average?
Well, off the cuff, that would be very difficult. We segment them depending on the product.
Okay, how
So
how how many products does your company sell?
we have a lot.
Uh-huh.
But
Okay.
if we put them, if we cluster them according to like,
Mm.
I would say we have I could talk about 42.
Ah, that's a huge number.
Yes, it is.
Okay. And what sort of products are you selling? Like which category are your products?
Well, I'm working for a mobile telecommunications company.
Okay.
So yeah, we have products for corporate customers and also for prepaid. So we've segmented them, and we look at youths, we look at the elderly, and in each of these categories, there are further products that are tailor made for them. So we talk about uh, it could be smartphones, it could be value added services. There are quite a number, I must say. Uh, Datta.
Okay. So basically, you are a sort of a service provider,
Yes.
right? All right. Now, does the average sales vary a lot every month?
No, no, they don't vary. We know our top products that give us like a lot of revenue,
Mm-hmm.
but they don't they don't change much now.
Okay, all right. So that means the average that she has, what Grace has, that's a good average. And then the variability that you have, that also needs to be controlled, because nobody likes to see that much of fluctuation in any business that you're doing, any sort of thing you are doing. You do not want a lot of fluctuations there, right? Then you are comparing it to two or more sets of data with respect to the validity, because what dispersion does is that, say supposingly, uh, Grace, do you people have a competitor?
We have two,
You
in
have
fact
two,
three.
three.
Yeah.
So there are four people in the market along with your company.
Yes, there's a new entrant, but the competitors that we have are two. One government institution, another Airtel. I'm sure most of
Okay,
people.
Airtel from India. Okay, so we are
Yes.
there. All right. So where at which number is your
Well,
company?
we believe we are the preferred network. We are number one.
You're at number one. Okay, all right. A loyal employee talking there. Uh, right. Okay. Fine. Now, if Grace's company wants to compare it with, say, Airtel, uh, so you look at the dispersion that is happening every month, and that means, like, say supposingly there is a consistency in Grace's company and there is a lot of dispersion in Airtel, then that means that the customers are not very loyal to Airtel and they're changing. So that becomes an opportunity for Grace's company to somehow change the marketing strategy and pull people from Airtel, because they are seeing that there is a whole lot of fluctuation happening at their end. If both of them are stable, that means people who are preferring her company are with her company, people who are preferring Airtel are with Airtel. Then again, you do not have a lot to do in terms of competition, but then you can always consolidate your position and you stick to where you are. And then the last one that we are talking about is, we talk about facilitate. When we say that you're facilitating the use of statistical other statistical techniques, uh, we use standard deviation or range or uh, mean deviation, skewness. We use that a lot for other calculations. When you are calculating other statistical measures are there you use a lot of these things. So yeah, so that is what the facilitating thing that we are talking about. Then comes the essential requisites, that what are the essentials of it, what do you want. So first we say that it has to be very rigidly defined. That means you define what you are trying to find out. Are you trying to find out the difference between the largest number and the smallest? Like Grace wants to find out the maximum sales, the difference between the maximum sales and the minimum sales. So then she should be using range. She wants to see that how much are we variating from the mean, like how much is the distance from the mean, then she should be using either mean deviation or standard deviation. Standard deviation is always a better thing. uh, she wants to find out an absolute measure, or she wants to find out a relative measure. If she wants to find out an absolute measure, let her go with standard deviation. She wants to go for a relative measure, let her use coefficient of variation. So these are all the rigidly defined. So you have to define that. Second, all the values, like yesterday when we were talking about mean, we said that one of the strengths of mean is that it uses all the values, and one of the limitations of mean is that it uses all the values. Right. So we saw the outlier problem there, and we said that outliers become a problem. And there you like, though out means outliers are always an issue. That's always an issue with us when we are doing our data analysis. But still, we say that whenever you're finding out the dispersion, all the observations have to be a part of it. Easy to calculate, of course, accurate, quick, of course. It should not be unduly affected by the fluctuations of sampling. So if there are any changes in your fluctuations that are happening in your sampling procedure, that should not affect your dispersion. And of course, mathematical and algebraic manipulations that we are talking about, yes. Now we come to the two measures that you have, the types of dispersions that you have. So first you've got the absolute measure of dispersion, and then you've got the relative measure of dispersion. When we talk about the absolute measure of dispersion, basically we are talking about uh, you are just taking a value, you are taking the value or the coefficient of a variable, and on the basis of that number that you have got, the value that you have, you calculate a dispersion. So that's an absolute measure. Now the issue with absolute measure is that it cannot be compared with others, right? You cannot compare it. So to make it comparable, you have got the relative measures of dispersion are there. So you have got the absolute measures like range, you have got interquartile range or deviation, and then you've got the relative measures where you are using uh, mean deviation, you are using standard deviation. So there like standard deviation and mean deviation are not relative. Like if you go for the coefficient, then it becomes relative. Otherwise, they are your absolute values. They are their absolute measures. Coefficient of variation, CV, that we calculate, that is always a relative measure. So we are talking here, we are saying that it contains the same unit as the original data set. It expresses the variation in terms of average deviations, standard and mean, and it includes all these: range, standard deviation, quartile deviation, etc. So first we are talking about range. Now this is what I was talking about. Okay, let me speak to uh, Salihu. You said you are in accounts department, or Usman said he's in accounts.
Yes, ma'am.
I'm not in account department.
You are in a business. Yeah,
Yeah.
Usman said that he's in.
Yes,
Okay, Usman in accountancy. You are writing the accounts for your company.
Yes, ma'am. There is some parts of the accounting procedure that I am prepared
Right.
for the company.
So you are not the one who is doing the journal entries and the postings and all those things, ledger postings. You are not responsible for that.
Yeah, I am the responsible person for the ledgers and the
Oh,
daily activities for
okay.
the company.
All right. So you have you have a head of petty cash.
Yeah, ma'am.
Okay. Uh, do you when does the petty cash number become a problem for you as an accountant?
No, ma. We have the procedure for the FETI in our organization.
How much
As
how much how much can you how much can you spend on a daily basis under the head of petty cash?
it's around 5 to 10,000.
Okay. Okay. Your currency is called what? Niger? No.
Naira.
Naira. Okay, yeah. I was near to it. Okay, Naira. Okay, Naira. So 5,000 to 10,000 Naira. Say
Yeah.
supposingly your boss comes to know that for the past 3 months it has crossed 20,000. What happens then?
Yes. So I can go through my record
Hmm.
and find out that the the
Hmm.
maximum things that consume a lot of money.
Okay. So, all right. Thank you. What I was trying to get from Usman was that you, like every month, they every on a daily basis they have that limit that okay you can spend this much amount. So they will have a day where they spend the maximum, and there might be days when they have spent the minimum. So if like next year when the budget takes place and when the decisions are to be made about this limit, they'll be looking at that range that is there, the maximum and the minimum, and from there they can say that okay, this is the maximum that was spent and this was the minimum that was spent. So that means we need to keep the petty cash allowances at this level. So that is how things are decided in companies. So it's one of the most easiest measure of dispersion to calculate, because it's just maximum minus minimum. So the maximum number that you have and the minimum that you have, that is a range. So the example here is like your 7 is the highest number, 1 is the smallest number, so the range is 6, because you're finding out the difference between the maximum and the minimum. Now so in many people say that a range should not be used because it's very easy, it's very simple, and doesn't tell you a lot of things. But in certain areas we just use the maximum, because so as to come to know the range, because that gives you a fair description about the data. So you've got an ordinal for range. You have the ordinal data set. You have presenting among people with little knowledge of statistics. So where do you, like, if you've got ordinal number, an ordinal numbers, that means you've got ranking. Then also you can use a range. You can use it with people who do not have a lot of expertise in statistics. So here is your range. Like here is are the monthly figures. So look here. Now, if you look, just have a look at it, the highest sales has happened in the 12th month, which is 92. And the okay. So 92 is the largest number that you have. This is the largest number that you have. And 80 happens to be the smallest number. So this is the smallest number that you have. So range will be 92. It will be 92. Okay, let me, this is, it will be 12. 92 minus 80, which is 12. So this will be your range. Now, how do you find out the coefficient of range? Now, why do you find the coefficient? You find the coefficient to make your data, comparable. So for making the data comparable, we use the coefficient. So any coefficient, when you're finding out the coefficient for anything, it makes it more comparable. So here, how do you calculate it? It's the highest minus the lowest, which came out to be 12, and then highest plus the lowest. So that is 92 plus 80, which comes out to be 172. So your coefficient is 0.069. So this becomes your coefficient, and there was no need to encircle it. So I'll just uh okay. Any doubts in the estimation of this, or anything that you have not understood so far? Please let me know. Anything that you have not understood or you need a clarification, kindly let me know. Mm. What time is it in your country, Grace?
It's 11:16
Okay, it's morning time. You
morning.
you went to the church.
This is around the time I go, so I missed out. I,
Okay.
I needed to ask, I'm a bit behind with coefficient of range.
Coefficient of range. Okay, right.
Yes, please.
Coefficient of range is basically, first understand the word coefficient. The word coefficient for anything, like if I say coefficient of mean deviation, coefficient of quartile deviation, the word coefficient is means that you are making your data scale free. So you are removing the scales from your data, and that when you remove the scale from your data, the scale of measurement is removed, then it becomes easy for us to compare the data. So coefficient is used to calculate to make your data comparable. So the formula for calculating the coefficient of range is the highest minus lowest, which is your range, up divided by highest plus lowest. So the in our example, the highest value that we had is 92, and like I have written here largest. Okay, so do not like it. I'm writing here it as L as large, not low, huh? So let me use the word H only. So this is H, and this is L. This is the smallest number that you have. 80 is the smallest number, 92 is the highest number. So this is 92 minus 80, which is 12. That's the range. And 92 plus 80 is 172. So 12 divided by 172 comes out to be 0.069. So this is the coefficient of range that we have. Grace, is it fine?
Very clear. Very clear.
Okay, thank you. Thank you. No, but I was getting less answers, so I thought, because in India it's 3 o'clock in the afternoon, so it's like the napping time for us on a Sunday afternoon after having our lunch. So I thought that's the reason I asked. So that means you people are all in the range of 11 to 12 right now. So everybody has had a breakfast, heavy breakfast, and dozing off on a Sunday.
Yeah, my place is like 1300 hours, 1300, 1320.
1300. Okay, that's 1 o'clock
Mm.
in your country.
Yeah, just after
Okay.
lunch. Yeah,
Okay, just after lunch. So Vasant, nodding
yeah,
off.
just a bit, man. Oh, no, not adding, but it's coming.
Yeah, it is there. It is there. Huh? So you can have a cup of tea or coffee with you.
Yeah, yeah, yes,
Yeah,
ma'am.
and you
Yeah,
can because I as a teacher can't do that. You as a student can always have a cup of tea or coffee, and you can continue with your class. Uh,
thank you.
that is that is what the fun of being a student. As a teacher,
Mm-hmm.
we can't do a lot of things on things.
Right.
And there is Usman laughing around, huh? Usman smiling away to glory. Uh, okay, all right. So now we talk about quartile deviation. Yesterday we did not we did not do any numerical on quartile. Though I told you that it is very similar to median. The only thing here is that in quartile you are dividing your data into four equal parts. In median, you divided the data into two equal parts. Here, you are dividing it into four equal parts. So, what happens is that very quickly, if I may write this. So, you have got Q1, which is basically your n plus 1, n plus 1 by 4. And then you have got, this is in the ungrouped series we are talking about. This is 3n plus 1 by 4. Please remember that median is equal to second quartile. So we do not calculate the second quartile. Either you calculate the second quartile or you calculate median. It's one on the same same thing. So it comes out to be, because both will show you the middle number, one which is dividing it into two equal parts. So therefore, we do not calculate that. Now, quartile deviation is what? Quartile deviation is basically the difference between the two quartiles. Q3 is known as upper quartile and Q1 is known as lower quartile. So the difference between the upper quartile and the lower quartile divided by 2, this gives you the interquartile range or quartile deviation it gives you. So we get here. Now, these are the numbers that you have got. Okay, 5, 7, 9, 12, 15, 18, 23, 32. So that means you have got how many observations do you have? You have 1, 2, 3, 4, 5, 6, 7, 8. You have got 8 observations in total. So that is 8 plus 1 by 4, that is 2.25. So 2.25th, now you do not have a 2.25th item, you have the second item and the third item. So what we do whenever such a situation arises, like whenever you have got even number of observations, you'll always have this problem. So what you do is, we took the second observation, which is 7, we took the third observation, which is 9, and then we found out the average, which comes out to be 8. So the first quartile is 8. Now for the third quartile, your formula is Q3 is equal to 3n plus 1 by 4. So n is 8, that is the total number of observations. 8 plus 1, that is 9 that you have. And that comes out to be 27 by 4, and which comes out to be 6.75th. Now again, you do not have a 6.75th item. So what you do, you took the sixth item, which is 18, you took the seventh item, which is 23, you took the total and you found out the average, which comes out to be 20.5. So 20.5 becomes your upper quartile. So now you find out your quartile deviation, which happens to be mm, what? Your quartile deviation will be 20.5, 20 point, let me change it. It will be 20.5 minus 8 upon 2. This is your quartile deviation. So that comes out to be 10.5. Sorry, 20.5 minus 8 is comes out to be 12.5. 12.5 divided by 2, which comes out to be 6.25. So 6.25 is your quartile deviation. Now tell me what you did not understand in this calculation. Uh, what have you not understood in this calculation? Kindly let me know what you have not understood in this. Yes.
Hi, Tanima.
Yeah.
I'm not very good with maths. However, I was trying to ask you,
Mm.
when do we use this quartile diversion, and is this the standard formula?
The
I'm
form,
kind of lost.
yeah,
Yeah.
the formula is standard. Your first question, that when do you use it? You use quartiles when you want to divide your data into 4 equal parts. So you want to say, like, let me come back to your company's sales figures. You want to divide the total sales into 4 parts, and you want to see that, okay, how many customers in the first quartile, how many customers in the third quartile, how many customers in the middle part, like, so which segment is coming where. So then you can use your quartiles over there to find out the sales, or very precisely, if I talk, like you said, that you are customizing the requirements of your customers in terms of the prepaid thing, that how much like in India what we have, the various things that if I take if I recharge my a mobile with 500 rupees a month, then I will get 2 GB data every day, and beyond 2 GB the speed will go down, and then there are certain add-ons to it, that I get a Hotstar subscription free of cost, or I get a free of cost music app. So this is what that is what I have understood that you are doing for your customers. Now you want to know that who are the customers, like you have got those four schemes, and you want to know that, okay, where are the what are the various divisions to it, that how many customers in each group. So then you can use your quartile over there, and you can do these, and the formulas are standardized. Grace, did I make any sense?
Yes, possibly. Maybe just tackle a question regarding the same, and maybe yeah, I can apply it. But basically, it's understood.
Okay, and the formulas are standardized. That means your quartile one will always be calculated by n plus 1 by 4 in an ungrouped data. Ungrouped data means when it is just the raw data, when you have not classified. If you are going for classification, then the formulas will change. Give me a minute. I'm just putting off my camera for a second. Just give me a minute. I'll just get my pen and pad, and so that I can write it for you.
All right.
All right. Uh, Now, when I say ungrouped data, basically what I'm talking about raw data. So again, coming to, if we are just talking about sales without we are just talking about their monthly sales without classifying it in various groups, then then she should be using mean, because then mean will be the best answer for her. But say supposingly uh, she wants to find out in the raw data, wants to find out one point which into two parts, like she wants that one point of sale from where she can divide them into two equal parts, then she should be using median. So what she does in median is she's doing n by 2. This is in case of like n plus 1 by 2 she is doing. And now if instead of these two parts, if I say that she wants to break them into 4 parts, then she goes for quartile. And in quartile, so what you are doing in quartile is you've got one here, you have this Q2, this is Q1, and then you've got Q3. So this I said that because this is the middle one, so this is as good as a median. So you need not calculate it separately. You need to calculate Q1 and Q3. So how do you do this? You do this by n plus 1 by 4, and you do this by 3 n plus 1 by 4. Now these are standardized formulas. There is you cannot change them. There is nothing that you can do to change them. Now say you have got grouped data. Now when I use the word grouped data, that means I'm talking about classified data. So she has got, like for example, I'm saying that Grace has 4 types of services. And now she wants to find out for these 4 types of services separately. So then she is classifying them, and then from each group, G1, G2, G3, G4, she wants to find out. So then she will be using the grouped data formula, which for Q1 is n by 4, and for Q3 it becomes 3n by 4. And from here there is no change in quartile deviation formula. I'm writing this in small so that you understand that what I want to emphasize. I want to say that there is no change in quartile deviation formula. That means quartile deviation remains the same. That is Q3 minus Q1 oblique 2. How you are calculating your Q3 and Q1 differs from the how the classification has taken place. Now again, say supposingly, again we are talking about Grace, and we are talking about uh, she classifies her data, she's classified her customers, uh, but she has done that in the form of a range. So she says that okay, for recharges from say her Grace, what's the minimum recharge for your company?
Beg your pardon? Minimum recharge for our company.
Yeah, what for how much can I the least amount that I can pay to get my phone recharged?
2 kwacha.
2 kwacha. And okay, then what is the next one after 2?
5,
Ah, okay, 2 5, and then
10, 15, and 20. The last is 50 or 100.
okay, so let's say 2 to 10, then I say 10 to 20, I say 20 to 50, and then 50 to 100 kwacha. Right.
Correct.
So this is basically the NUUS continuous series. So this is the continuous series that we are talking about. And here you can then she can write the number of customers. This is the recharge range, and this is the number of customers. So which range do you have the maximum customers, Grace?
It's the low value. So
2 to 10,
between 2 and 10 years.
2 and 10. So supposingly she says that I've got 500 customers here, I've got 300 here, I've got 25 here, and then I've got say 35 here, right? So this. So now from, if this is the data, if she's presenting, if she's classifying her data this way, and now she wants to calculate her quartile, so here the formula will become one. There will be again two stages. One is n by 4. This will give her the, this will give her the quartile class. And then from here she has to, once she gets the quartile class, then she puts in a formula that, which is very similar to the median formula, L1 plus n by 4 minus CF upon F into I. So this is for quartile 1. For quartile 3, it will be 3 n by 4. So there is no change in the quartile deviation formula, but yeah, the quartile things will change. This is as good as a median. Okay. So if you are practicing it for median, it will be the same for quartile, only the denominator will change, because here you're dividing it into 4 equal parts. If this would be decile, then it will be divided by 10. If it is percentile, it will be divided by 100. So that's the only thing that is changing. Otherwise, nothing is changing, but there is no change in the quartile deviation formula. Have I confused you more, or is it okay? Have I confused you people more, or is it fine?
No worries, it's fine.
It's fine. Okay, Usman says it's okay. Grace, I think so. I've made life more precarious for you.
Yeah, yeah.
Yeah. Okay. Because more formulas came in, huh? More formulas came in. But I can't
Let's
help it.
give me
Yeah, in statistics, you have to use a lot of formulas. So you need to do that. But if you understand the concept, the basic things, that in median you are dividing it into 2 parts, in quartile you are dividing it into 4 parts. So if you understand that, then it becomes easy for you to do the other part.
sure.
Yep. Yeah, sure. So easy to say. I know. All right. Okay. Let me come back here, and let us move ahead. This is the quartile. This is the coefficient again. So as we have already said, that coefficient is basically a measure to make your things more comparable. So here it's Q3 minus Q1 upon Q3 plus Q1. That is how you do it. So here now, all right. So let us do this numerical for you. Let me do it for you. If you can of course copy this in your like you can click a picture, copy it, whatever you want. Here now, this is the total. So this is basically your summation F. And how did we find out the cumulative frequency? Yesterday also we did it, but just for a reminder, this is 394 plus, like, 394 plus 461 is equal to 855. Then 855 plus 391 is equal to 1246, and so on. So the last cumulative frequency that you get and your summation F, they should be always equal. So that is how you see whether you have calculated it correctly or not. And then we want to find out the first quartile. So what we do is Q1 is equal to n by 4. So it's 2010 by 4. So which comes out to be how much? People with accountancy background need to be quick and let me know the answers. This comes out to be 502.
502.5.
Yeah, thank you. So 502.5 comes out. So you then go and see this. You see this in cumulative frequency. So obviously 394 does not include 502.5. 855 includes your 502.5. So this becomes your quartile. This becomes your lower quartile class, Q1 class. Similarly, so now if I want to find out Q1, so now my second stage is L1 plus N by 4 minus CF upon F into I. So this is how you do it. Uh, this is how you do it. So you measure it as L1 will be how much? 41. So that is 41 plus 502.5, which is basically your this. Then comes minus CF. So minus CF, when I'm saying minus CF, so CF is the cumulative frequency of the preceding class. So preceding class to 41 to 80 is below 40. So this becomes my CF here. So I write minus 394. Frequency I'll be taking of the quartile class. So this comes out to be 461. What is my class interval? This is 81 minus, 80 minus 41. Somebody please do the calculation and let me know how much is this coming out to be. Somebody please solve and let me know how much is this coming out. Somebody please just calculate the entire thing and let me know what the answer you are getting to it. 502.5 minus 394 comes out to be 108.5 by divided by 461 comes out to be 0.23. Multiply that by 39 into 39. It comes out. Okay.
If I'm correct,
Uh,
it's 21.94.
no, that should not be your answer because as we said 502.5 minus 394 is
0.13.
108.5. Yeah, so you divide that by 461, which comes out to be 0.23. You multiply that by 39, which comes out to be 9.17. So 41, this comes out to be basically uh, 41. Where is my pen? Okay. Okay, somewhere it has. Where is the pen gone? Mm.
50.13.
Yeah, it will be 50. Your answer should be 50.17. 50.17 should be your answer. 41 plus 9.17. Your answer is 50.17. Are you getting this answer?
Got 50.14.
14, okay. 50.14. I'm just stopping the sharing because my the PPT got stuck. Technology has got its plus and minus. L Alt L. Microsoft PowerPoint and task. All right. Just a second. Let me reopen. Did everybody get that answer? 50 point, how much? 1714, something like that.
My own is 49.97.
Why? Why? What? I think so. It should come out to be. Dispersion. Doing 50.17 should be the answer. Got it or not? Or need I do it again?
Let's try again.
Let's try again. Okay. All right. As it is, my all the calculations went haywire. Like it all went away. Don't save, and then you have this one. All right. So let's again start our sharing. A tab. No, cancel. Share a window. All right. This was a question, and 41. Okay, so very quickly. Okay. So Q1 we are measuring. So we said the first part was clear, which was n by 4, which was basically 2010 divided by 4, which came out to be how much? 512.15? How much was it? 502.5.25. All right. So we now use the second one, which is L1 plus n by 4 minus CF upon F into I. This is your formula. So the lower limit is 41. So this is 41 plus 502.25 minus cumulative frequency, the cumulative frequency of the previous one. So that is 394. So 394 divided by the frequency, that is 461. The cumulative frequency is 394 here. This is what I is class interval. So just for you to know that I is class interval, which is basically L2 minus L1. So L2 is in this case your upper limit is 80. So it's 80 minus 41. So sorry. So this is 80 minus 41. So now you solve it. So it comes out to be 41 plus This is only 5, huh? This is 5. This is 5. So 502.5 minus 394, that's 108.5 divided by 461 multiplied by 39, because 80 minus 41 is how much? 39, isn't it? So you multiply, if I now 108.5 divided by 461, so which comes out to be 41 plus 0.23 times 39. So this comes out to be 41 plus 239. This comes out to be 9.17. So the answer comes out to be 50.17. So this is your quartile 1. Is it fine with everybody? Is it okay?
Yes, ma'am.
Yes, yes.
Yes, yes.
Now Grace gave a big yes. Okay, so fine. Thank you. Now the next step is next step is to find out quartile 3. So this is 3 n by 4, which is n by 4 was how much? 100 and what? 2010 divided by 4 was 502.5. So this comes out to be 1507.5. So I again go and check this in my cumulative frequency. So this becomes my third quartile class. This was my first quartile class. So this 121 to 160 becomes my things. So now I again, to find out the third quartile, my formula is L1 plus 3n by 4 minus CF upon F into I, which comes out to be, my lower limit is 121. So that's 121 plus 1507.5 minus the cumulative frequency of the preceding class. So that's 1246. So 1246 upon frequency of the quartile class, which is 334. So 334 into my upper was 160 minus 121. So again I solve this 121 plus minus 1246. So this comes out to be 261.5 divided by 334 times 39. So this is 121 plus divided by 334. This is 0.78 times 39, which comes out to be 121 plus 30.53. So this comes out to be 151.53. Is this calculation okay with everybody? Have you understood this calculation?
Yes.
Grace, are you with me here? People with who have got these. All right. So you have also understood. So let us now come to quartile deviation here. So now we
Tamim,
yeah
Tamim,
yeah.
yeah, Godfrey. I have a question
Mm,
for the first calculation. Yeah, sorry.
mm,
The first
mm.
first calculation, you said that you found 502.25. Is
No, that's
it
five
the
zero
first one?
five 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 zero
But
502.5. 502.5.
okay, all right.
Yes.
Yeah, sure. It should be like that. Okay, all right. Okay, thank you.
Uh, okay, so my quartile deviation is equal to Q3 minus Q1 oblique 2. So my upper quartile is 151.53. My lower quartile is 50.17 divided by 2, which comes out to be 151.53 minus 50.17. 101.36 divided by 2, so 50.68. So your quartile deviation is 50.68. Your coefficient of quartile deviation is equal to Q3 minus Q1 oblique Q3 plus Q1. So this is 50.68 divided by 151.53 plus 50.17. So this comes out to be 151.53 plus 51 point, sorry, 50.17. So this comes up to be 2. So this is your coefficient of quartile deviation. Any doubt so far? Any doubt so far in the calculations? Anything that you have not understood? Yes, Vasant.
No, ma'am, all good. Yeah, all good.
Okay.
Thanks.
Okay. Anybody, any questions, any doubt in the calculations? Anything that you have not understood? All right. So I know it might be taking a bit of time for you people to uh, digest these calculations and how we are doing it. So we now move ahead and we move to mean absolute deviation. Now, mean absolute deviation is we are talking about it's the average difference between each variable or each observation and the mean that you have got. So that is what you are calculating. So when we were talking, when we saw range or when we talked about quartile deviation, we were not talking the distance of each observation from a central value. So it was more of a more a sort of a you can say that it was more about the placing of the observations or the situation of the observations that was more important rather than each observation. Now, when you're talking about mean absolute deviation, or when you're talking about, we also call it just simple mean deviation. Here, you are very much interested in finding out the difference of each individual observation from the central value that you have calculated. So, the whatever the central value you have calculated. Now, in this case, though the name is mean deviation, you can always find out the difference from a median and mode as well. So though I'm repeating that though the name is mean deviation, so people say that you find out the difference from mean, but it's not necessary that you find out the difference always from the mean. You can also find out the difference from uh, median. You can also find out the difference from mode. So it will be called mean deviation only. The beauty of this is the why mean deviation is a better tool than range or quartile deviation is because here you are talking about each observation's difference from the central value rather than talking about it in a generalized term. So this is a much better measure. Now, okay, a lot of things that I've written here earlier. So let me just remove them and then let us talk about it. So, and then let's speak about this. So this is what mean deviation looks like. This that you are seeing here, these two lines that you are seeing here, they are called modulus, or in short we call them mod as well. And what does mod stand for? Mod stands for that the symbol will be ignored. That means when you are using modulus, you are not using the okay, it again got stuck. uh, is happening. uh, mm, let me again open it. And either the file is getting too heavy. Mm, okay, so we were here. So if we now want to, so here, as I said, that these two, this stands for modulus, which means ignore the sign. Here you want to say that you are ignoring the sign. That means the difference from the mean is sign indifferent. Or you can say that it is um, like the plus or the minus sign is not having any meaning here. So what you are doing is you are finding it out. Like if you're talking from a population point of view, it becomes mu. You can forget this. You can forget this for now. Forget for now. You can forget this. You can just you can, yes, somebody has raised their hand or somebody is coming in. I
Yes,
can't
yes.
see. Yeah,
We can't see the.
you cannot see the presentation.
Yes, yes.
Okay, because I have not shared it. Ha ha ha. Okay. Okay, I got so engrossed teaching that I forgot that I have to share the PPT as well. Ah. Sometimes you do certain idiotic things. Okay. Is it Farida? Is it okay?
Yes, it is. Thank
Okay,
you.
thank you. Thank you. Thank you for reminding me. Otherwise, I would have gone ahead. All right. Okay. So, as I was saying, okay, I was saying that these two bars are known as modulus, which basically means you ignore the sign. People who have done basic mathematics know this. And so what we are inferring here is that the difference from the mean is sign indifferent. That means whether you are getting a plus sign or a minus sign, you are ignoring both these signs. You are ignoring both of them, and you are just taking the absolute number and you are finding it out. So you if you if in case of ungrouped data, you use this formula, and in case of grouped data, you take this formula. So that is basically the difference here. You are just taking, if you're finding this formula a bit difficult to understand, you just write it like this. You can just write it like this. So it's x minus x bar modulus upon n, summation modulus x minus x bar upon n. And in case of grouped data, it will be summation f modulus x minus x bar upon n. And n in this case is summation f. So instead of writing n, okay, let's make it a bit more easy. Let's not do this. Summation f. Okay. How are we? Are we fine? Are you people?
What's X bar?
X bar is
Sorry.
mean, darling.
Okay.
That we did yesterday. That's X bar is mean. How many are tired seeing all these things? People who love numbers, who are comfortable with numbers, I suppose it's okay. As it is, the number of people have gone. Okay, there are still 12 people there. Okay, fair enough. Okay. Now the question is that where are you going to use it? Fine. That's the most important question. That where am I going to use this? Why is Tanima teaching all this? Tanima is teaching all this to you so that you can uh, use them for your company's figures. And of course, I know, I do understand that you cannot share your company's figures here with all of us, but if you have some numbers and like sales numbers, your customer numbers, your production numbers, you can always use these formulas to see how much of difference is there, how much of deviation is taking place from the central value, to understand that how good your average is. So we said in the beginning, when we started with dispersion, we said that how good your that measure of central tendency is, how reliable that number is. To understand the reliability of that number, it's very important to go for such sort of calculations to see. So one of them is mean deviation, because you're talking about each and every observation here. So this is a very good measure of dispersion. So you can use this. Yeah, Farida, you want to say something? You're
Mama,
holding your head. You're holding your head. So it's too much.
not too much, just very interesting. I love figures as well, but so yeah.
Acha, you love figures, then to it's a cakewalk for you. People because you just imagine, Farida, your the number of customers that you are getting every day, or every month, or every quarter. And then you want to say, because a lot of your strategy making is based on that average that you're talking about. So average sales, average production, average, it's always about the averages. And it is very important for us to have that average to be very reliable, something that you can count on. So if I want that number to be very reliable, I need to do these things and see that how reliable they are, how much am I deviating from that. Because then the next strategies will depend on the deviations that are taking place. Like I'll give you an example from India, so that I make some more sense to you. If you are into textile business in India, in clothes making, the sales are very much correlated to the festivals that you have. So there are certain colors which are more in demand in certain festivals, and your sales peak and come down as per the festivals. So you have got a festival of colors known as Holi. There's a festival of lights which is known as Diwali, and then you've got Dashera, Diwali. You've got, so these are the peak seasons when you do a lot of sales here in India, like from the Indian perspective, if I'm talking about. Now, they say the companies see that how much are they deviating from the average, and therefore you'll find that the advertisement expenditure uh, quadruples up, or goes beyond 4 times during these festivals than in other periods, because the companies know that people are going to buy new clothes during this, so it makes sense for them to advertise it more in that season rather than in other seasons. So all these online e-commerce websites as well, whether it's Mintra, whether it's with the other shopping like the clothes shopping things, like you've got Tata Click, and there are other websites from where people buy a lot of clothes. So they also come out with a lot of their sales options during that season, and they come out with new collections and everything during that season, because they know that the sales is going to happen during that period. It's the same, I suppose, in your countries during Eid or during Christmas and New Year. The sales figures should be going up for things like this. That is what I'm presuming. Like in India, if you're talking about even the automobile, like automobile sales, um, clicks 2 times in India. There are 2 seasons when you maximize your sales. One is year ending, because then the prices go down because your model changes. So that is one time when people buy a lot of new automobiles. And then it's Diwali, when people buy a lot of Diwali and Dashera. There's hardly 15 days between these two festivals. So people are buying like around about 22 days differences there between these two festivals, and that is when people buy their maximum number of cars and scooters and all your refrigerator, all the white goods that you have. So they buy all these white goods a lot during this period. So companies come out with new models at that time. Companies come out with great offers during that time. So people are waiting for it for these festivals to come. So I think so you can resonate with what I said in terms of your industries and the companies in which you're working. I think so I made some sense. Made means it a bit clearer for you people. Okay, coming back here. Let us do a few more numericals. Uh, now this is the coefficient. This is the coefficient of mean deviation, which is basically your mean deviation divided by mean times 100. The reason we are doing it times 100 is because we want it in terms of percentage. So we want it in terms of percentage. That's the reason we are doing it times 100. Percentages are easy to understand. It makes life a lot easier for people who are not very good with numbers. So somebody tells you in terms of percentage, so you know that okay, out of 100, that is what they are talking about. So here, let me just go back and let me keep this and let me remove these. Okay. And okay, so here we are talking about a hospital, and we are talking about an emergency ward. And we are saying that the number of patients seen in the emergency ward of a hospital for a sample of 5 days in the last month were so. Determine the mean deviation and interpret. So, what I do first is I first find out the mean, which is me and my drawing skills. All right. So, this is how I reached to my mean x bar, which is basically x bar is equal to, people who have forgotten the formula, it's summation x by n. So I added all these numbers and I divided by 5, so I got 152. Now what I do is I find the difference of each of these observations from the central figure, which is my mean, which is 152. Now this is modulus. In a mean deviation, I said that you take the modulus. That means you ignore the negative sign. So it's 153 minus 152, which is 1, 147 minus 152, which is 5. Though it's a negative 5, somebody has raised their hand. Okay, if somebody, I can't see you people, I can just hear the sound. So if somebody has got a question, kindly unmute yourself and go ahead. This is how you have calculated the deviation. So here it is. You have you have taken away these signs, the negative sign here, the negative sign here. You have removed them, and here you are. So the total is coming out to be 12. So your mean deviation comes out to be 12, which is summation of x minus x bar. That is 12 upon 5, which comes out to be 2.4. Now, because we are talking in terms of patients, so we are approximating it to 3 patients, because you cannot have 2.4 patients. So on an average, every day there is a deviation of 3 patients. So you can say that from 152, you may go to 155, or you may come down to 149 patients. So this is the range of patients that you'll have, that is 149 to 155 is the range of patients that you are having on emergency, like in the emergency ward. The average is 152. Now my question, there are two questions from me. One, is there anything that you have not understood in the calculation? Is there anything that you have not understood in the calculation part? Is there anything that you have not understood in the calculation part? Vasant, are you there or dozed off?
Yes, ma, we understand everything.
Okay, Suleiman, thank you. Now, Suleiman, if you may answer, because you opened your mic, so I'm putting you on the dock.
Okay.
Should this hospital, should they change their strategy, or is it acceptable? This 3 deviation is acceptable. Anybody else can also answer. Should the hospital change its strategy with a deviation, mean deviation of 3, or should it stay put with the strategy, because this is not a very significant number? Yes.
I think, ma, we should first know the coefficient of the deviation so that we could think of if we need to change the strategy or not.
Okay, so let's calculate the coefficient as well. All right. You can go ahead and you can calculate the coefficient. The something is not compatible. You can calculate the coefficient, like till the time I open my PPT. You people can always calculate the coefficient. Coefficient is basically mean deviation divided by mean. So mean deviation was 3. Your the mean deviation that you had is it visible? Is my PPT visible?
Yes, ma'am.
Yes, it is.
Okay. So the coefficient, if I want to calculate the coefficient is equal to mean deviation by mean times 100. So it comes out to be 3 by 152 times 100, which is how much? Uh, now, Suleiman, give me the answer. Should the company change or should the company remain?
No, I think since the deviation is not that much, they can still retain their own strategy and move
Yeah,
on.
so yeah, because it's just 1.97%. So that's not a very significant difference, right? So you stay with your strategy. Uh, I hope it is clear to everybody. Are there any questions? Yes, go ahead.
It is clear and it's making sense.
Okay, it's making sense. So let me stop the class here and we meet again in the, like, for me it will be night, like evening, late evening, 7 to 9 I've got a class, and we'll from there we'll continue with standard deviation. We'll look at standard deviation and then we'll come to the next topic of sampling. And if you have any questions, you can ask right now, or we can take the questions in the evening as well. But whatever is fine with you, uh, because there are still 5 minutes uh, for this class, so you can always ask me. You can always ask me the questions that you have, like. So okay, so let's meet in the evening.